Okay, so the final question on paper 2 is all about momentum. So figure 13 shows a cannon before and after it is fired. Before it is fired, the cannon is stationary. When the cannonball is fired, the cannonball moves backwards and the cannon moves backwards and the cannonball is moving in the other direction. The arrows show the direction of movement of the cannon and the cannonball. Explain why the cannon moves backwards. Well, this comes down to the underlying principle behind this, and this is something we call the conservation of momentum. The conservation of momentum states that in an event like this, and this is what we call an explosion, another type of event might be a collision, momentum is always conserved. That is, if I add up the momentum of all of the things beforehand, it must equal the momentum of all of those things after. Here, before, my momentum is 0 kilogram meters per second. This is my unit for momentum. Why? Because momentum, P, equals mass times velocity. Mass in kilograms, velocity in meters per second. If you're multiplying them together, this is what you get out as your unit. Okay, so afterwards, my momentum of the cannonball and cannon must also be 0 kilogram meters per second. But we have the cannonball moving forward and we have the cannon moving backwards now. So surely they both have mass and they both have velocity. How can they add up to 0? What's happening here is we're seeing the vector nature of momentum. A vector is a quantity with a size and a direction. Since the cannon is moving backwards, it has a negative momentum. The cannonball is moving forwards, therefore has a positive momentum. When you add the positive momentum of the cannonball to the negative momentum of the cannon, they have the same value, so we add up to 0. But let's express that in writing. So why does the cannon move backwards? The conservation of momentum states that momentum is conserved before and after an event. Is conserved when an event occurs. In this case, this is the explosion of the cannon, the cannonball and the cannon moving off in either direction. Before the explosion, the total momentum of cannon and ball is 0 kilogram meters per second. Therefore, after the explosion, it is also 0 kilogram meters per second. Since the cannonball has a forward, or I'm going to say positive momentum, because I'm saying that's a positive direction, the cannon must have a negative momentum brackets move backwards in order for momentum, total momentum or should I say the momenta, to sum to 0. Okay. 7.2. The mass of the cannon is 1500 kilograms. The mass of the cannonball is 10 kilograms. The cannonball moves forward at a velocity of 67.5 meters per second. Calculate the velocity at which the cannon moves backwards. Well, we've just said that momentum before equals momentum after. The momentum of something equals its mass times velocity. So, the momentum before was 0. So 0 equals the momentum of the cannon and cannonball afterwards. So momentum of cannon plus momentum of ball afterwards, which I've just said is m and v. So 0 equals m of cannon times velocity of cannon plus the mass of the ball times the velocity of the ball. Let's start putting some numbers in. 0 equals the mass of the cannon, 1500, lots of its speed, plus the mass of the ball, which was 10 kilograms, times the velocity of the ball, 67.5 meters per second. 0 equals 1500 times the speed of the cannon plus 675. Therefore, 1500 times the speed of the cannon equals minus 675. I'm moving that 675 over. And the velocity of the cannon equals minus 675 over 1500. I'm going to express that as a number. In order to do that, I'm going to need to open up a calculator, and we get minus 0.45 meters per second. And that is fine to have a negative number, because if the cannonball's moving forwards with the velocity of 67.5, the cannon must be moving backwards. That's what that negative sign means. The cannon's moving in the other direction. Notice it's moving a lot slower as well. That makes sense because the cannon is much more massive, it's much heavier, so it recoils, goes backwards slowly. And that is the end of the paper 2.